So here we have a bog standard oscilloscope, and we're just going to show you the basics of this. We currently have it connected to a signal generator, so we'll be able to show you a waveform in a minute. And this is pretty standard basic lab kit really, so we've gone for one that's not overly complicated. Although they have so many switches and knobs, it's possible to have it in the wrong state, so that's the first thing we'll go over. So when we first set this up, we want it in a stable state. You have no idea how someone else may have left it, so basically the first thing is to set this to channel 1 and this switch here to ground. That way you should just get a basic trace. So first thing we'd do is look at the intensity and focus and just make sure that's clear really, so it doesn't look fuzzy like that, just a nice sharp line. The trigger levels here, they're not really relevant yet. This button's labelled X, Y should be depressed, hold off should be fully anti-clockwise, and this position knob is basically to just make sure the trace is visible there. So you can see the way it's going off screen there, so you should have it sort of centered. This is the vertical position of the first channel. So obviously this is a 2-channel scope. That's your channel 1 input, and that's the channel 2 input. With the time base here, basically you set it so you've got a nice steady line to start with, and this var sweep, have that fully clockwise, and I think you should be able to match what I've got there at that point. Now we have this set up currently displaying a approximately 1 kilohertz sine wave from our signal generator here. Now we've got this connected via a little adapter here that allows you to plug in using 4mm leads, just to make everything a bit easier. Okay, so let's have a look at how this is actually displaying this now. So of course it's showing a particular frequency, and this will be set to a particular amplitude or voltage, which is set on the dial here. Now so we can take a measurement here by how your voltage per division is set. So on this one, if we look in there closely, it's currently pointing towards 0.5. What that means is each square going vertically represents 0.5 of a volt. So basically, to work out your amplitude of your wave displayed, you just basically need to count the squares. Now some oscilloscopes will actually have measurement capabilities, but even without, it's pretty quick thing to be able to do. And of course you can just set it to whatever you need depending on what amplitude you've actually got there. So obviously it depends on how big a signal you've sent to it. Okay, so then we look over at the time/division time base control, which is over here. Now that's going to show you how it looks if you think about this scale here. So there I can sort of spread it out or bring it in. Now obviously this is what a scope's about. It's showing you an image, a graphical representation, if you like, of your input signal. So you can actually take a measurement of the time on this as well by basically looking. If you look at your dial on the time base, it will point to a number. Say here it's pointing to 0.2, and so that's 0.2 milliseconds. It's on the millisecond scale here. That's 0.2 milliseconds per square going left to right. So basically, if you want, you could calculate the frequency of this wave by simply counting up your squares between over a time period, and then with a little calculation you can very quickly work out the frequency, which is basically what we call the reciprocal. You put it's 1 over the time, so that's basically that. As you can see, I can also alter the frequency, and you'll see it change as I increase it on there. Sine wave's a good one to use as a demonstration because it's easy to see what's going on. Could set it to a square wave like this. That'd be like a typical square wave if you were looking at, say, data, and looking at data lines to see what they were doing. Now, one thing you might wonder is the what people refer to as this being set to either AC or DC coupling. Now, that really depends what you want to measure. AC, if you want to measure predominantly the AC component or an AC wave. DC for DC levels, DC current. So that's basically it, really. It depends what you're trying to measure. Of course, you could look at AC when you're measuring what should be a DC input. You might be looking for what we call ripple current. If a power supply is potentially not as clean as you think it, or what it claims to be. Now, we'll have a little talk about triggering. Now, I'd recommend to start with, just to keep things simple really, so keep the hold off fully round, anti-clockwise there, and you've got your source as channel 1, so you'd set your trigger source to channel 1, and again, for simplicity's sake, keep the coupling on auto. Now, the trigger level basically is, you think of it as wanting to be able to see a stable image. So if I move it round off position there, you'll see you've now got an image that you can't really do anything with, so it's just sweeping across the screen. So basically, you can imagine it just looking for a point that it can trigger when moving it up, and there you go, you get a stable image. So that's something you need to set. You obviously don't want it sort of just rolling along when you're trying to measure an input. Obviously, this is just a sine wave. If you're measuring an audio signal, of course, it would be not as simple a waveform as that. But that's basically what I would do. Particularly, this is just, you're measuring a single channel at a time. Okay, so we're now looking at a battery pack which is using all 4 cells. We're getting 6 volts, or should be getting 6 volts, I should say. So on the screen here, it's currently AC coupled, so of course we're seeing nothing. So if I move it down now, that's through the ground line, and then down to DC, you can see now you've got a DC level. It's just a steady line. But if we were to look at the setting here, which is on 2 volts per division, 2, 4, 6 would be there. So it's actually saying it's slightly lower than what it should be. So one or more of these cells is not producing quite what it should be. But that's basically what a DC line will look like. So that's it basically. Now, just to quickly show you this is a cheap and not necessarily cheerful bench power supply, which is producing a DC current. Now, if you look here, it's set, if you look on our multimeter, around about 6 volts. But, so you'd expect from that a nice clean line, wouldn't you? So, but if I show you over here on the scope, obviously it's going to be a bit of a flicky image there, but basically that is supposed to be DC. So the fact that it's not a nice straight line shows you that there is a ripple current in there, and basically these power supplies are not smoothed very well. There's no rectification in there, so it's DC, but it's not a very clean DC. So there, if you're using something like that, you'd have to be careful what you're actually trying to use it for. So the scope shows that up really well, that it's not all DCs are the same. So just another couple of little points to go through here. So there could be a possible time you would want to measure more than one signal at a time, and obviously this being a 2-channel oscilloscope, you can do absolutely that. So literally you would connect another source to your second channel and you'll see 2 traces on the screen, and yeah, that's basically it. You can measure them and compare them. That might be a key reason you'd want to, of course. Okay. Now, as I said earlier, the XY button, generally, I don't suspect you'd need that day to day, and it's quite a specific thing, really. So I'd leave that depressed. But just to say, if you're using that, basically you can make some comparisons between 2 signals, and you can look at the phase difference between, and sometimes they use it in educational situations to try and create different shapes on the screen, circles and things like that, if you've got your 2 frequencies perfectly matched. But I think general fault finding, you probably are not going to need that too often. So I think that's about it, really. Oh yes, one other thing. If you're using a probe, which you probably would generally, rather than straight leads a lot of the time, so you're sort of poking around looking for faults, one thing to bear in mind is when you're measuring with a scope is that it is referenced to ground. You're going to have one connection here, this dangling connection connected directly to a ground, and so you're measuring from ground to wherever you're probing. So it's not like using a multimeter if you wanted to look at a potential difference. If you wanted to look at anything like that, you either need to use what we call a differential probe, or it can be done using both inputs, but you've got to be quite cautious about what you're doing there. But it's worth remembering that's how you're measuring with a scope, and obviously you've got to use certain precautions depending on what it is you are measuring. I think that's generally about it. Of course, this does have an external trigger, so you could have it clocked by something externally. But that's about it, really. So really, I think the best thing to do is just get a scope and try it with a battery, try it with a couple of different signals, maybe audio signals, and just play around and see what they look like. But like I said at the start, the first thing I'd always do is just get it into a position where you know that all the basic settings are correct to start with. Make sure it's not been set up in a strange way. And I think that's generally about it. But if you have any other questions, of course, down in the comments below. Thank you for watching.